So today we're going to use our graphing calculator as an example to do a problem. So our goal is to use a graphing calculator to find the equation of the line of best fit. And what we've been given is we've been given a data table that shows the number of minutes, which is y. So the number of minutes and the total distance of a running race. So we have the number of minutes per kilometer is in green, so like their pace based on the distance of the race. So that's our data set. So if we're going to use our calculator, of course, I'm just following the directions that we were given in class. So the first thing we would need to do is to start to enter our data. So on my graphing calculator here, I am going to go ahead and start entering my data. So in my stat, edit, I have a bunch of data here, so I'm going to scroll up to the top and clear it and hit enter. Scroll over to the top of L1, hit clear, and then enter. So as we as we said, we're going to enter our x's into L1, which I'm going to do. So 6.2, 9.3. So I'm just entering the data from the table in the order it was given to me. I don't need to organize the data at all. I can just type it in. And then the y values are going to go into L2. Just make sure I don't have any typos or anything. I think it looks good. I just double check. Everything looks like it's typed right. And what I am noticing is there's 1, 2, 3, 4, 5, 6, 7, 8, 9 data points. And when I go down here, it tells me that this is the 9th data point. So I have my data entered. So I'm going to go to y equals and make sure I have nothing on. Like I have an equation from the last one in here. So I'm going to clear that out. I'm going to hit second y equals to go to my stat plots. I'm just going to use plot 1, so it's good that the other two are off, so I'm going to go inside to make sure the settings are okay. It is on. It is making a scatter plot, and I do have my x's in L1 and my y's in L2, and that's where I just put it. So that's all good. So I'm ready to go. Before I hit my, before I make a picture, I'm going to have the calculator set the window for me. I'm going to hit zoom, and then option 9 will zoom to the stats, or in other words, the data that I've given it. So I'm just going to hit 9. So here, this is that data plotted, and it's a scatter plot. If I hit the trace button, I can go through those data points. So like here, x was 12.4, the y value is 5.9. That's what I should see here. So it allows me to go through the data points if I use the trace button. So I have the data entered, so I actually need to get the line of best fit. So that's where I'm going to hit stat. And I know I'm going to calculate something, so I scroll over to calculate, and this looks like a line, so we're going to use the linear regression, so option 4. So I do have my x's in L1, I do have my y's in L2. I'm not using a frequency list, because this doesn't tell me anything about a frequency list, and we won't use that in Algebra 1. But I do want it to store the equation, so after it figures out the equation, I know I need to write it down on my paper, but I also want my calculator to store it so then I can graph it and make sure it actually is a good line of best fit. So here again, remember, I want to store it to y1 or like a y variable, so I'm going to hit the variable button. I'm going to look for the y variable, so I'm going to scroll over. It's going to be a function because it's a line, and I want it to be stored in y1, so the first equation of my y equals. Then I go down and hit calculate. Now I do need to write this down, so like for my equation, I'm going to come over here and just make sure I copy the information. So for me, I know it tells us the equation is in slope-intercept form. So the slope is the number before x, which is a. So the a value here is our slope, so it says 0.0543. I'm just going to round that. X, and then plus, and it says the b value for this equation. The b value is 5.20. And I'm going to round it to that decimal place, so 5.203. So that's my line of best fit. And if I go back and look at my calculator, it will have already entered that into my y equals, and it won't round, it'll put all the decimal places. But you round, that's okay. If I hit the graph button, it'll show me that that line of best fit is a really good line. It goes through most of the data, it has about 4 below, 4 above, so on and so forth. So I was able to create the line of best fit. wants me to identify and interpret the correlation coefficient. And remember, the calculator tells us a few things we don't need. R squared is nothing to us. The correlational coefficient is just R. So it's good to remind yourself of that, that we're just looking for the R value. So in our case, R was given to us as 0.982. So it always tells us two things according to our notes. The correlational coefficient should first tell us, based on the sign, if it's positive or negative, and this R value is positive. So what does that tell us? The first thing we know is that there is a positive correlation between our two variables, which is the number of minutes per kilometer and total distance of the race. And that makes sense. As the total distance of the race, x, as that gets bigger, so as the race gets longer and longer and longer, my average pace should be getting slower and slower. Now the second thing it tells us, okay, there's a positive relationship, but the second thing will tell us the strength of that relationship. Is it a good fit? Is it a bad fit? And since this value is very close to 1, this would tell us it's a very strong correlation. So again, the correlational coefficient always tells you two things: the type of correlation, whether it be positive or negative, and the strength of that correlation. Last part, or the next part, is we need to interpret the slope and the y-intercept. So our slope, m, was given to us as 0.0543. I like to represent that as a fraction, just because it's always easier to represent slope as a fraction. So we know that slope is describing the change in y over the change in x. So for us, y, which I'm just going to type, the y value was given to us as the number of minutes per kilometer. So number of minutes per kilometer. And then the denominator was x, which was just the total distance of the race. So I know that when I see this fraction, I know what it's describing to me. So what I can see here is, if I connect kind of here, the total distance of the race was 1, and that's a positive 1. So as the total distance increases by 1, so as, and here's x, the total distance of the race increases by 1, or in other words, we see a +1 on the bottom. Well, what is the number of minutes per kilometer doing? Well, the number of minutes per kilometer is being described by 0.053, and again, that's a positive number too. So as I increase my x value by 1, so as I increase the total distance of the race by 1 kilometer, the number of minutes per kilometer increases by 0.0543 minutes. So again, we're making sure that we are identifying the value and the increase or the decrease in both our independent and our dependent variable. The y-intercept of this line, that's our next portion. The y-intercept, which I'm just gonna, I guess I'll do down here. So the b value was 5.23. Now the b value we know came when x was equal to 0. So it's our starting pace. So the y-intercept is always a starting value. So the runners start at a pace of 5.203 minutes per kilometer. And then we know is that the slope will tell us as the race gets longer, their pace will go up. So most people will be capable of starting at running at that pace. So now we want to approximate the average number of minutes per kilometer when the distance of race is 13.5. So we can see we don't have the answer to that in our data set. We have a bunch of different races, but we don't have any races that are exactly 13.5 kilometers long. So what they want us to do is they want us to take our equation and they want us to approximate what that pace would be. So for us, what they've given us is they gave us the distance of the race was 13.5 kilometers. And we know the distance of the race, that's our x value. So they gave us the x value. So what we're going to do is we're simply going to replace that x value with the value that they gave us. So we'll still have y equals 0.0543. So that's a point. But instead of x, we know that they want the x value to be the total distance, which is 13.5. And then we're supposed to add 5.203. So now since I'm using my calculator can tell me that math there. So I'm going to go to my home screen, so second, quit. And if I want to figure out y, what is that total, that time per kilometer, what I would need to do is I'd hit 0.0543, and I would multiply that by 13.5. And then I have to add 5.203. So I'm just typing in the left side of the equation here into my calculator and hitting enter, and it tells me 5.936. So as a sentence, what that would tell me is for a race that is 13.5 total kilometers long, right? That's my x value. The average number of minutes per kilometer is 5.936. So if I'm running a 13.5 kilometer race, I average 5.936 minutes per kilometer is another way of writing that. Now, the last part of that question is it does want to know, so we just used our line of best fit to make a prediction. There's two different types of predictions that we've been talking about. We've been talking about interpolation or extrapolation. So they want us to know what type of prediction is this. So I just like to use my calculator for that to help me visualize where is this prediction being made. So this is our data here, and they were asking for the x value of 13.5. So if I use my trace, and just kind of find where is x, and here I don't want to trace on my plot, I want to trace on the line, so I can use up and down to change what my cursor is going to go through. So on the line, I'm just going to find the x value of 13. So 13 is like here, it's inside my data values. So because the prediction I'm making is inside my data, I know that this is going to be interpolation, because we are predicting something about a value inside the current data we have. If I would have asked about something, let's say that's like, so our last data point, our biggest data point looks to be about 27.9. If I asked to make a prediction about 30 or 40, that's outside of the data. But this x value is inside of our data, so we're having interpolation. So that'd be one full problem that you would be doing for your homework today. We entered the data into the calculator, used the calculator to calculate the line of best fit, talked about our correlation coefficient, interpreted the slope and the y-intercept, and then used the equation that our calculator gave us to predict something.